Hey everyone, welcome to The Explainer. Today, we're doing something pretty cool. We're going to take apart something you probably use literally every single day, but we're looking at it through a completely new lens. You see, today's car is no longer just a collection of metal, gears, and grease. It's actually a highly complex digital network on wheels. We're going to break down the incredible anatomy of the future car, looking at everything from how a vehicle manages millions of lines of code, to the physical power distribution, and finally, to the energy sources driving the whole transition towards sustainable mobility. Let's dive into this.
Here's what we're covering today, point by point. First, system complexity and domains. Second, body and power distribution. Third, modern infotainment pillars. Then, regenerative braking technology, followed by automotive energy sources, and we'll wrap up with the transition to sustainable mobility.
All right, let's jump right into part one. System complexity and domains.
So to really grasp how a modern car works, you've got to realize that the sheer volume of electronics and software packed inside is just staggering. Honestly, if we didn't organize this digital chaos, the car simply wouldn't function. To manage all this tech, engineers must first describe different functional domains to explicitly tackle the problem of system complexity. I mean, you can't just wire 100 different computers together and cross your fingers, right? Dividing a car into functional domains is the absolute ultimate solution to this massive challenge.
So how do engineers actually pull this off? Well, first, they map the network architecture. Think of this as drawing up the master blueprint for the car's digital nervous system. Next, they actively address that system complexity by grouping related tasks together. Third, they establish those functional domains. It's kind of like setting up specialized departments in a massive corporate office. You've got your powertrain department, your safety department, your body control department, and they're each focused on their specific job without stepping on each other's toes. And finally, they define the exact requirements needed to make these car functions a reality. By organizing the software this way, the whole car operates seamlessly.
Moving on to part two, body and power distribution.
Okay, so we've looked at the digital brain. Now we need to talk about the physical components. How does the actual vital energy move through the vehicle's chassis to power all those domains we just talked about? Well, that brings us to power distribution. This is the fundamental system that guarantees the effective movement of electrical energy inside the car. If the functional domains are the brain, power distribution is totally the cardiovascular system, pumping that electrical lifeblood to every single sensor, motor, and screen. Let's quickly trace the path of this energy through the fundamental parts of this cardiovascular system. It kicks off with the battery, your primary energy reserve. Power generation then hands off to the alternator, which creates power while the engine is running, working right alongside the starter to get the whole mechanical process going. But, this energy needs highways, and that's the wiring harness, literally miles of hidden cables in the chassis. Along these routes, fuses and relays act as safety gatekeepers to stop overloads. From there, we hit the brains of the operation, the electronic control unit, or ECU, which directs traffic, and the CAN bus, which is the communication network letting all these parts talk to each other. And in modern engineering, this architecture has to flawlessly manage both traditional low-voltage systems and the massive high-voltage systems we find in modern EVs.
Let's shift gears to part three, modern infotainment pillars.
Stepping inside the cabin, we enter the specialized domain that dictates how you, the driver, actually interact with the vehicle. Modern infotainment is built on 5 very specific pillars: tuner, media, navigation, Bluetooth, and projection, which refers to things like Apple CarPlay or Android Auto. In the past, the radio was just a radio. Today, these 5 pillars drive total user connectivity. But the future of these systems is way beyond just playing music. The strict focus is heavily on safety, deep personalization, and seamless connectivity. It's all about making sure the driver stays perfectly informed without ever having to take their eyes off the road.
Next up, part 4, regenerative braking technology.
We're transitioning here from features of comfort to a highly specific modern engineering marvel designed entirely around efficiency. So I want you to think about this question. What exactly is regenerative braking? See, in a traditional car, when you step on the brakes, the kinetic energy of the moving car is turned into heat by the brake pads, and that energy is just totally lost to the air. It's wasted. But what if simply stopping your car could actually generate usable power? Here is exactly how this ingenious system reclaims that energy step by step. Step 1, the driver applies the brakes, or honestly just lifts their foot off the accelerator. Step 2, this is where the magic happens. The electric motor actually reverses its function. Instead of using power to push the car forward, it acts as a generator. Step 3, that forward momentum, the kinetic energy, is actively captured and converted right back into electrical energy.
And step 4, this newly generated electricity is sent back through that power distribution system we discussed earlier and stored in the battery for future use. It's a brilliant loop for reclaiming what used to just be wasted.
All right, bringing us to part 5, automotive energy sources.
So we've mapped the systems, the power distribution, and the efficiency tech. Now we really need to understand our key automotive energy sources. Grasping their distinct advantages and disadvantages is absolutely vital for understanding the industry's monumental transition to sustainable mobility. Because let's be real, you can't design the car of the future if you don't understand how you're going to power it.
Let's break this down side by side. Looking at conventional energy, like gasoline and diesel, the pros are significant. You have incredibly high energy density and a massively well-established global fueling infrastructure. Diesel even offers great fuel efficiency and high torque for heavy vehicles. But the challenges are steep: high tailpipe emissions, environmental concerns, and a total reliance on finite fossil resources. Now contrast that with electric energy, specifically battery electric vehicles. The pros here directly solve those conventional problems. You get zero tailpipe emissions, high efficiency, and super low operating costs. However, they face their own set of challenges, right? You've got the environmental impact of battery production, the heavy need to build out new charging infrastructure, and limits on driving range. It's a really complex balancing act of pros and cons.
And that leads us perfectly into part 6, the transition to sustainable mobility. Ultimately, when you look at how all these components, domains, and competing energy sources culminate, there isn't just one single immediate winner. The reality is that multiple energy sources are going to coexist in the future automotive landscape. The internal combustion engine isn't vanishing overnight, and electric vehicles are rapidly scaling up. So to be truly industry-ready, modern engineers must understand and actively innovate across all these technologies simultaneously. They literally have to master the power distribution of a gas car and the regenerative braking of an EV.
So I want to leave you with this provocative thought to chew on. As system complexity continues to skyrocket, how will the next generation of engineers perfectly balance these coexisting energy sources in the coming decades? Will we see entirely new functional domains created just to manage wild hybrid architectures? The anatomy of the car is evolving faster than ever, and understanding this intricate underlying architecture is your key to keeping up. Thank you so much for joining me on this explainer. Keep learning, keep questioning, and I'll catch you in the next one.